Our universe is an endless treasury of mysteries. From the birth of galaxies to the death of stars, each discovery opens a new door while simultaneously posing countless unanswered questions. Among them, black holes have always been one of the strangest and most captivating phenomena, places where physics seems to bend beyond belief. We're familiar with supermassive black holes lurking at the hearts of most galaxies, like Sagittarius A in our own Milky Way. We also know about stellar mass black holes, born from the collapse of massive stars. But what if a stellar mass black hole turned out to be so massive it challenges every theory we've ever built? Welcome to Quiet Void. Today, we're diving into the story of Gaia BH3, a groundbreaking discovery announced by the European Space Agency, ESA, on April 16, 2024. This stellar black hole, with a record-breaking mass, is not just a new milestone, but a true game-changer in how we understand the death of stars and the formation of the universe's most enigmatic objects. Before we dive into Gaia BH3, let's quickly refresh what black holes are. Essentially, a black hole is a region in space-time where gravity is so strong that nothing, not even light, can escape. They are the final, collapsed remnants of an object. We typically categorize black holes into two main types. Supermassive black holes, weighing millions to billions of times the Sun's mass, reside at the centers of most galaxies. Then there are stellar mass black holes, typically ranging from 5 to 20 times the Sun's mass, formed when a massive star exhausts its nuclear fuel and collapses in a violent supernova explosion. Until now, we've found dozens of stellar mass black holes in the Milky Way, mostly by observing them feeding on matter from a companion star or through gravitational waves when two black holes merge. But Gaia BH3 is unlike any stellar black hole we've ever seen. It all began with ESA's Gaia mission. Gaia is a space telescope tasked with precisely mapping the positions, motions, and characteristics of billions of stars across our Milky Way. Think of it as a cosmic traffic cop tracking every tiny wobble and movement. Among the mountains of data Gaia collected, scientists noticed a peculiar star, an old, faintly luminous giant star in the Gaia catalog. What was remarkable was that it was dancing strangely, not orbiting a visible object, but an empty point in space. That wobble was the unmistakable sign of an extremely strong gravitational pull from an unseen object. After ruling out every other possibility, like an unseen star or a massive planet, the only conclusion left was that it was a black hole. And when they calculated the mass of this invisible object based on the companion star's movement, the result was staggering, 33 times the mass of our Sun. For perspective, the second most massive stellar black hole known in the Milky Way, Cygnus X1, is only about 21 times the Sun's mass. Gaia BH3 is nearly 1.5 times heavier. Interestingly, Gaia BH3 is relatively close to us, just 1,926 light-years away in the Aquila constellation, making it the second closest known black hole. It's located in the inner halo of the Milky Way, a region containing older, metal-poor stars compared to the galactic disk. So is its companion star. Spectroscopic analysis revealed it to be a metal-poor star, with heavy element content over 100 times lower than the Sun's. This is a crucial detail, as it hints at an unusual black hole formation mechanism. For decades, the prevailing theory of stellar black hole formation suggested that when a massive star dies in a supernova explosion, it loses a huge amount of its mass through powerful stellar winds or the explosion itself. This limits the mass of the resulting black hole. For example, a 60 solar mass star might leave behind a 10 to 15 solar mass black hole. Metal-rich stars, in particular, lose more mass due to radiation pressure. Conversely, metal-poor stars, like the progenitor of Gaia BH3, are thought to lose less mass during their evolution and collapse. This leads to a fascinating scenario. What if a truly massive metal-poor star could collapse without undergoing a typical supernova explosion that strips away too much material, or with only very weak stellar winds? In that case, the resulting black hole could retain nearly all of its parent star's mass. However, other scenarios, such as interactions in a binary system or a double black hole system, are also being explored. Gaia BH3 provides real-world evidence for such a scenario. At 33 solar masses, it lies within the so-called mass gap, a range of masses that previous theoretical models suggested stellar black holes couldn't achieve. Its very existence forces us to reevaluate our models of how the most massive stars evolve and die, especially in metal-poor environments. This discovery is also critical for gravitational wave astronomy. Observatories like LIGO and Virgo have detected black hole mergers, some resulting in black holes far more massive than expected. Gaia BH3 helps us better understand the origins of these monsters, suggesting they might form directly from the collapse of massive stars. Gaia BH3 isn't just a record-breaking number or a strange object. It's a critical clue. It suggests that our galaxy might be home to many more super-heavy black holes than we ever imagined. Black holes we haven't found yet because they aren't actively feeding on matter and thus not emitting X-rays. Having a monster black hole like Gaia BH3 so close to Earth, just 1,926 light-years away, is a huge advantage for scientists. They can now use powerful telescopes, both ground-based and in space, to study its companion star in greater detail, better understand its orbit, and infer more about the black hole's true nature. This discovery once again validates the irreplaceable value of comprehensive mapping missions like Gaia. They don't just paint a detailed picture of the Milky Way. They inadvertently reveal the universe's deepest mysteries, things we didn't even know we were looking for. Data from Gaia DR4, expected in late 2025, may uncover more such systems. Gaia BH3 is a powerful reminder that the universe never ceases to amaze us. Every time we think we've grasped one part of it, a new discovery emerges, shattering assumptions and opening deeper questions. This colossal stellar black hole isn't just a new record, it's a gateway to new insights into the birth and death of stars, the formation of the most enigmatic objects in space, and the grand structure of the cosmos. It may even be linked to the ED2 stream or a disrupted globular cluster, adding intrigue to its origins. What are your thoughts on Gaia BH3? Do you think we'll find more super-heavy black holes lurking in our Milky Way in the future? Share your thoughts and questions in the comments below. If you found this video fascinating and want to explore more cosmic mysteries with us, don't forget to like, share, and subscribe to Quiet Void so you don't miss our next exciting journey into space.